Part 1. Copy and complete the table below. So this table, you need to copy it out and figure out what goes in the other 4 boxes. Answers in the second row must be in index form. So the first answer is technically 2 to the power of 1, and the second one is 2 to the power of 2. So our 4 other answers need to be 2 to the power of something, so they need to be a base of 2. Hence, write 2 to the power of p plus 1 minus 2 to the power of p as a power of 2. So hence means using what you've figured out in the previous question. So something here is going to help us to work this out. And then part 3, hence or otherwise, solve for x. 2 to the power of 12 over 16 is equal to 2 to the power of x plus 1 minus 2 to the power of x. So presumably what we've worked out in part 2 will help us with part 3. So the first part of this question is quite easy. It's simply a case of inputting into the calculator and your answer rewriting as a base of 2. The second 2 parts are quite tricky. But if you do this part correctly and you have a look and see is there a pattern forming, it should help you to work this bit out. And once you've got this part worked out, it will help you to work this part. So let's have a look at the first box or the first column and see how we got 2 here. So if you input into the calculator 2 squared minus 2, you will get 2, and 2 can be rewritten as 2 to the power of 1. And if you input into the calculator 2 cubed minus 2 squared, you will get 4, and 4 can be rewritten as a base of 2 as 2 squared. So we'll do the same thing into the calculator, 2 to the power of 4 minus 2 to the power of 3, and you will get 8, and we can rewrite that as a base of 2 as 2 to the power of 3. Next, input into the calculator 2 to the power of 5 minus 2 to the power of 4. You will get 16, and 16 can be rewritten as 2 to the power of 4. Next, input into the calculator 2 to the power of 6 minus 2 to the power of 5, and you will get 32, and 32 can be rewritten as a base of 2 as 2 to the power of 5. And finally, input into the calculator 2 to the power of 7 minus 2 to the power of 6. You will get 64, which can be rewritten as a base of 2 as 2 to the power of 6. So the actual answers, what we're looking for, is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6. So focusing in just on all the 2's, so we can forget about the 2, 4, 8, 16, 32 and 64. We're only interested in the 2's and their powers. So let's have a look and see is there a pattern. 2 to the power of 2 minus 2 to the power of 1 gives us 2 to the power of 1. So just focusing on the powers, 2 minus 1 gives us 1. Next, 2 to the power of 3 minus 2 to the power of 2 gives us 2. So just focusing on the powers, 3 minus 2 gives us 2. 2 to the power of 4 minus 2 to the power of 3 gives us 2 to the power of 3. So just focusing on the powers, 4 minus 3 gives us 3. In the next one, we have 5 minus 4 gives us 4, 6 minus 5 gives us 5, 7 minus 6 gives us 6. So hopefully you notice that each of the first numbers, so we've got 2 to the power of 2, then 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. So each of those first numbers, the number that comes after it, the number that's subtracted, the power is 1 less. So 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4, 6 minus 1 is 5, and 7 minus 1 is 6. And in the same way, we could say 6 plus 1 is 7, 5 plus 1 is 6, 4 plus 1 is 5, 3 plus 1 is 4, 2 plus 1 is 3, and 1 plus 1 is 2. So there's a pattern. Now let's have a look at the answers. Notice that the second number was 2 to the power of 1 in the first column, and the answer was 2 to the power of 1. In the second column, the second number was 2 squared, and the answer was 2 squared. In the third column, the second number was 2 to the power of 3, the answer was 2 to the power of 3. Then we have 2 to the power of 4. The answer is 2 to the power of 4. 5 and 5, 6 and 6. So the answer is always the same number as the second term, or the power of the second term. So there's a pattern, there's a few patterns that we can see. So part 2 says hence, so using something that we've noticed here, something in the patterns, 2 to the power of p plus 1 minus 2 to the power of p. We have to write this as a power of 2, so as 2 to the power of something. And we're going to write that as 2 to the power of p. So let's have a look and see how we got 2 to the power of p. We got it somehow down here. So in the first column, we had 2 squared minus 2 to the power of 1 equals 2 to the power of 1. So we can write it out here. 2 to the power of 2 minus 2 to the power of 1 equals 2 to the power of 1. In the second column, we had 2 to the power of 3 minus 2 to the power of 2 gives us 2 to the power of 2. So I've written that out here. And in the third column, we had 2 to the power of 4 minus 2 to the power of 3 gives us 2 to the power of 3, which I've written here. We don't need any more. We'll see the pattern in the 3 that we have here, but if you wanted to, you could do the same with the last 3. Okay, so let's focus in on this a little bit closer. So if the p is 1, then p plus 1 makes 2. So technically that 2 is really 1 plus 1. So if 1 plus 1 gives us 2, then p would be 1. So the answer, p, is 1 as well. So we know that this is true. We know that this yellow statement is true. So this is what we're trying to come up with. If we have a look then at the pink statement. So if p is 2, then p plus 1, so 2 plus 1 is 3. So then we end up with 2 squared as our answer. So again, that p must be 2. In the third statement, the orange statement, if p is 3 and 3 plus 1, so p plus 1 is 4, and our answer is 2 to the power of 3, so the power is 3. So the answer is p. So this statement makes sense. So 2 to the power of p plus 1 minus p gives us 2 to the power of p. So whatever the first power is, so in the first example it's 2, then it's 3, then it's 4. It's always 1 more than the second power. So if the second power is p, so 1, 2 or 3, then the first power was p plus 1. So 1 plus 1 makes 2. 2 plus 1 makes 3. 3 plus 1 makes 4. So the first power was always 1 more than the second power. And then the answer always matches, or the power of the answer always matches the power of the second term, or the second power. So 2 to the power of 1, 2 to the power of 1, 2 to the power of 2, 2 to the power of 2, 2 to the power of 3, 2 to the power of 3, and so on. So if this is 2 to the power of p, then this must also be 2 to the power of p. So question 2 said hence, so using a pattern that we noticed here, write 2 to the power of p plus 1 minus 2 to the power of p is a power of 2. So it's going to be 2 to the power of p. So now we're going to use this statement, this equation that we've set up, and we're going to use it to solve part 3. So part 3, hence or otherwise, solve 2 to the power of 12 over 16 equals 2 to the power of x plus 1 minus 2 to the power of x. So this is what we worked out in part 2, and we're going to use this to help us solve this. So if you just focus on the right hand side of the equation, 2 to the power of x plus 1 minus 2 to the power of x. It is pretty much the exact same as 2 to the power of p plus 1 minus 2 to the power of p. The only thing that's different is we have p's here, and now we have x's. And we know that this is equal to 2 to the power of p, so this is going to be equal to 2 to the power of x. So I'm going to write down this statement again, but instead of p's, I'm going to have x's. So I have 2 to the power of x plus 1 minus 2 to the power of x is equal to 2 to the power of x. Now we know from this statement that 2 to the power of x plus 1 minus 2 to the power of x is equal to 2 to the power of 12 over 16. So we're going to rewrite this as 2 to the power of 12 over 16. So we have 2 to the power of 12 over 16 equals 2 to the power of x. Now all we have to do is rewrite this as a base of 2. When the bases are equal, we can cancel the bases. We'll be able to cancel the 2's. And then we can let the indices equal each other and solve for x. So 2 to the power 12, which is our numerator, stays as 2 to the power 12. And 16 we rewrite as 2 to the power 4. And the right hand side stays the same. Next, we're dividing powers with the same base, so we subtract the powers. So it's going to be 2 to the power 12 minus 4. The right hand side stays the same. And 12 minus 4 is 8, so we have 2 to the power of 8. Now we have the bases matching, so we can cancel the bases. We can cancel out the 2's. So we have 8 is equal to x. So we're asked to solve for x, so x is equal to 8.